Hey everybody, we've got some new formulas to show you, and also we've got some more friends who are going to help show us their laws. Okay, now as you can tell, we've got Boyle's law, and so I bet that some guy named Boyle came up with it. So let's see if I can find Robert Boyle. Hey everybody, Robert Boyle here to tell you about my law. My law is Boyle's law, and the independent and dependent variables of this law are V and P. That means volume and pressure. Now, since those things are my variables, that means that those things is going to be changing. So, yeah, if some things are going to be changing, then that means that some things are going to have to be constant. The constants for my law are T and N. That means temperature and number of moles. Guess what? This formula is an inverse formula, meaning that the two variables, when one goes up, the other one goes down. And my formula is V1 P1 equals V2 P2. The way you can remember that, picture my face here. You see my face? Picture me as a vice president, okay? Vice President Boyle, Robert Boyle here, Robert Boyle for vice president, okay? That's how you can remember that I deal with VMP. Boyle is the VP. Thank you, folks. Thanks, Robert Boyle. Appreciate that information. Let's go ahead now and take a look at your good friend Charles's law. Charles's law. Now, I only want to look at one at a time, so I'm going to try to... what's going on? Let's see here. All right. Charles's law. There we go. So, let's see if we can meet Jock Charles. Hey, y'all, Jock Charles here, Jock Charles. Yep, that's right. That's me. The two variables in my formula are T and V. Yep, TV for Jock Charles, T and V. That means temperature and volume are going to be changing in my law. The controls for my law are pressure and number of moles. That's P and N, P and N there. Guess what? This one is actually a direct relationship between your variables. That means when one goes up, the other one goes up as well. My formula for my law is V1 over T1 equals V2 over T2. And that, my friends, that is the formula. V1 over T1 equals V2 over T2. You can remember that by, look at this mug. Look at my mug here. Isn't my mug beautiful? Isn't it good enough to be on TV? You see what I did there? You see what I did there? Yeah, so you're going to remember Charles on TV. Charles is on TV, and that's how you can remember that my variables are T and V, temperature and volume. Thanks, folks. Thanks, Jock Charles. That was awesome. Let's go ahead and look at Gay-Lussac's law next. Let's see here. Here's my friend Joseph Louis. Oh, Joseph Louis Gay-Lussac. Hello, everyone. My name is Joseph Louis Gay-Lussac, and I have a gas law, and it deals with the P and the T. P meaning pressure, of course, and T meaning temperature, of course. The control variables for my law are V and N. V being volume, of course, and N being number of moles, of course. This one, just like my friend Charles's law, is also a direct relationship between my variables. That means that as one goes up, the other one goes up. The formula for my law is P1 over T1 equals P2 over T2. That means the original pressure over the original temperature is going to be equal to the final pressure over the final temperature. Yes, indeeders. That, my friends, is my law. Yep, I think that's all you need to know. Oh, how can you remember it? I don't know. Just remember it. Just come up with something awesome. My name is Joseph Louis Gay-Lussac, and you can probably come up with something. Thanks, Joseph Louis Gay-Lussac. That was awesome. Next, we have our good friend. Oh, no. What happened? Oh, no. Where am I doing here? Oh, there it is. Next, I've got my good friend, Avogadro. His name is Amadeus Avogadro. Amadeus Avogadro. Yes, that is me, Avogadro here. My formula is the Avogadro's law, and my independent-dependent variables are V and N. V, of course, meaning the volume, and N, of course, meaning the number of moles. That means that I do have to have some controls, and the controls are going to be P and T, pressure and temperature. My law as well is a direct law, meaning that as the number of moles increases, the number of volume also increases. My formula is V1 over N1 equals V2 over N2. Yes, so the original volume over the original number of moles is going to be equal to the final volume over the final number of moles. Yes, that is my law. Thank you, sir. Appreciate your information there. All right, now we can take all of these scientists' law, okay, all of their laws, and we can combine them all into the combined gas law, which is where we have all variables present, V, P, T, and N. Are there any control variables? No. Everything changes. It's craziness, okay? Everything's going to change. The mathematical relationship is NA, okay, meaning not applicable. And so now what we're going to do is we're going to see how to work with some of these laws. All right, now here's the deal with these gas laws. Okay, we have to always take a look at what we're given in our problem. Okay, so this says a 5.20 liter sample of gas. Okay, liters refers to volume, so I know I've got some kind of volume there. Is heated from 25 degrees Celsius to 100 degrees Celsius. So those are temperatures. What's the volume in liters at the higher temperature if the pressure and the amount remains constant? Okay, so V and N are constant. Okay, the only thing that's changing is my pressure and my temperature. Okay, so I've got a P1 and a T1, meaning my original pressure. Excuse me. Wait. I'm sorry. P and N stay constant. And my volume is changing. My V1, so I've got an original volume and original temperature. I'm going to have a final volume and a final temperature. Okay, so my original volume is 5.20 liters. And my original temperature is 25 degrees Celsius. Now, hopefully a lot of y'all are already seeing the issue here, okay? As I told you in the first video, you cannot ever have a Celsius situation in a gas laws problem, okay? So it tells me what is the volume at the higher temperature. So I'm looking for V2. I'm just going to call it V2. And my final temperature is 100 degrees Celsius, okay? Now, as we know, I have to convert T1 and T2 to Kelvin, okay? So I've got 25 plus 273 equals 298 Kelvin is what we're going to use for T1. I've also got 100 plus 273 equals 373 Kelvin for my T2. Okay, so now I'm going to write my equation. I know that I'm dealing with Charles' law here because it's V and T. Okay, Charles watches TV. So I've got V1 over T1 equals V2 over T2. Okay, so what that means for me now is I need to just plug and chug. Okay, so V1 was 5.20 liters divided by T1, we changed it to 298 Kelvin, equals V2 is unknown over T2 is 373 Kelvin. Not bad so far. And so now all I've got to do is cross multiply. And so I get 5.20 times 373 equals V2 times 298. Okay, now if I want to get V2 by itself, I'm just going to divide both sides by 298. Easy as pie. Cancel, cancel. And so now I'm going to do this math, and I see that V2 is 5.20 times 373, enter, divided by 298, enter, and I get a final answer of, let's see here, I need correct number of sig figs, 3, 3, and 3. So I need 3 sig figs, so therefore my answer is 6.51 liters. Okay, That's my final answer, 6.51 liters. And of course, since T and B were changing, I know that this was Charles' law. Okay, we'll do another couple of problems in the next video just to make sure that you fully understand how to do this. But that'll do it for right now.